Today, we'll learn about variation. There are three main kinds. Direct variation, where we say that y varies directly as x, or y is directly proportional to x. That means that a change of x changes y by some magnitude k. We have y equals k times x. Raising x by 1 means you multiply y times k. If your job pays by the hour, your pay varies directly as the hours you work. If we let P be your total pay and H be the hours you worked, then the equation is P equals KH, where K is a constant. In this case, K would be your hourly wage. In some problems, it's easy to see what K is, in others, it's less clear. But notice that direct variation is a linear equation. Y equals kx is linear. We'll assume that everything's positive. Then the graph of y equals kx would look like this, a line. With inverse variation, an increase in x leads to a decrease in y. An example would be the temperature of the ocean varies inversely with the depth. So if T is temperature, then it equals K divided by D. As the depth increases, the temperature decreases. We'll get to graphs of inverse functions later in the course, but a graph of y equals k divided by x would not be a line. It's a decreasing curve like this. We'll also see problems where y varies jointly as two variables, and there are a few different versions of this one. You might be told that y varies jointly as p and q. In that case, it's directly related to both. The equation would be y equals k times p times q, everything multiplied together, with k the constant of variation. You may see a problem where y varies directly as p and inversely as q. In that case, we'd have y equals k times p divided by q. P is in the numerator, Q is in the denominator. Here's another example. The volume of a cylinder varies jointly as the height and squared radius of its base. So if you recall, the volume of a cylinder is going to be the area of its base, which is A, times the height, and A equals pi r squared, where r is the radius of that circle. So the volume of the cylinder would equal k times h times r squared, and in this case, k equals pi. I'm on page 51 now. The electrical resistance of a wire is directly proportional to its length. A 35-foot long wire has a resistance of 2 ohms. Work through the steps below to find the resistance of a 100-meter wire. Step 1, choose the letters and variables. We're given resistance in ohms, so I'll have that be R. And we're given length in feet, so I'll have that be L. Write a variation equation without numbers. Okay, so we want to set up this relationship based on the information we've been given. We're told that resistance is directly proportional to length. That means that R equals K times L, where K is the constant of variation. Step 3, find K. We're given 2 ohms equals K, that's a K, times 35 35 feet. So if I divide both sides by 35 feet, I'll have K equals 2 ohm over 35 feet. And you can put that into decimals, 0.057 ohms per foot. That's what ohm over foot means. And so our formula then will be R equals 0.057 L. Now we need to find the resistance of a 100-meter wire. Pay attention to the units here. We can't just plug in 100 for L because our constant of variation expects feet. We want to multiply by something that's measured in feet so that the feet will cancel and will be left in ohms. So first let's convert 100 meters to feet. So it's 100 meters, and we'll want meter at the bottom and feet on top, and there are 3.28 feet per meter. I just looked that up on Google, and that gives us 328 feet for the length of our wire. So our resistance will be R equals 0.057 ohms per foot times 328 feet, and that's a whole number, so it just divides by 1. Now notice the foot will cancel, and 0.057 times 328 gives us R equals 18.7 ohms. And that's our answer. That's the resistance of the wire. Problem 2. Interest varies jointly as principal and time. If we know that $2,000 left in an account for 4 years earns $320 of interest, then work through the steps below to find how much interest would be earned if you deposit $5,000 for 7 years. Step 1, we have interest, which will be I, and that's measured in dollars. We have principal, P, which is also measured in dollars. And we have time, T, and that's measured in years. Set up the equation. Okay, interest varies jointly as time and principal means that it varies directly with both of them. So the equation is going to be I equals K times PT. Let's plug the values from the problem into the equation and find K. We have that the interest is $320, and that equals K times $2,000, which was the principal, times 4 years, which was time. Now, if we divide by 2,000, we can get rid of the dollars. So that would give me $320 over $2,000 equals K times 4 years. So the dollar goes away, and that gives me 0.16 equals K times 4 years. So let's divide both sides by 4 years. And that will give me that K equals 0.16 divided by 4 is 0.04. And I have a year on the bottom, so it's like 0.04 divided by year, which is saying 0.04 per year. So that's the interest rate. You're earning 4% interest per year. Now to solve the problem, if you deposit $5,000, then that's the principal. So we're given that P equals $5,000 and that T equals 7 years. Plugging that into our formula, we get I equals 0.04 divided by year times $5,000 over 1, because that's just a whole number, times 7 years, also over 1. And if you see, the year is going to cancel, and the only unit that's going to be left is the dollars, which is what we want. We want the interest that we earn to be in dollars. So we have that I equals 0.04 times 5,000 times 7, which is 1,400. I equals $1,400.